Hi everyone, this is video 4 dealing with pointers. This is an important video because it shows you probably the biggest advantages of using pointers in C++ programming, and that's the dynamic allocation of variables. This program is program 916. I've pulled it straight from the book, no modifications other than maybe taking some comments out to make it a little more readable for you as you follow along with my explanation. This program declares 3 integer arrays. It makes duplicates of those and prints both the original and the duplicates out. All right. In walking through my code, I change things around. It's just a preference of mine. I always like to put my functions first instead of using prototypes. It's just a preference. You guys are experienced enough now. You all can decide what's best for you. I don't consider either one right or wrong. And I'm not even sure if in the industry there's somebody, I don't know if there's even a preference to what's good programming and bad programming. But like I said, I put my functions first. Mainly, I think it's to keep down from the errors dealing with prototypes. It just seems like I always end up fighting it when I'm writing a program. All right, I'm going to go down to main and start walking through this and refer back up to my functions. In this, I declare 3 integer arrays of 3 different sizes. You can see them here. I've got int array 1 of size 5, and I made it multiples of 100 up to 500, 100, 200, 300, 400, 500. And when I say I made, it was, like I said, this is from the book, 916. All right, I did a second array, size 7, multiples of 10 up to 70, and a third array, size 10, counting numbers up to 10. All right. Next thing I did is I declared 3 integer pointers, right? At this point of the program, these are integer pointers. Dup1, that's duplicate, so it's dup1, dup2, and dup3. I assign them all to null pointers, so they're not pointing to anything right now. All right, this is when the duplication kicks in, this next line. Let's look at this. All right. I am calling a function, duplicate array, and I'm sending it array1. Look how I've got that written. I don't have that with any brackets. And this was a big disconnect for me when I was learning programming. I guess I didn't really connect the fact that this array1, all right, was pointing to the first element in the array. All right. So this is basically this is a pointer, array1, to the first element in this array. And the same way here too, array2, there's no brackets here. So this really, in essence, is a pointer to the first element in array2. And the same with array3. So what I'm sending this function is a pointer to array1, size of 1, which is 7. And then in the second one, I'm sending an array2, size 5 for the first one, size 7 for the second, size 10 for the third. But I'm sending pointers to all of these first elements. Like I said, that was one of the hard things for me to understand when I was making connections with this when I was first learning programming. So I'm sending a pointer to duplicate array of each of these 3 arrays. Let's go up. We're going to go up and look at the code. And another thing about this function is we can see right now, it's going to return a pointer. Right? It's going to return an integer pointer. Dup1 is an integer pointer. So this function, duplicate array, which we're sending it a pointer to an array and a size is going to return a pointer to an integer. So let's go up and look at this. All right, here is duplicate array. Right? It's going to be taking in a pointer and an integer. Right? That's what it's taking in, and it's going to return a pointer to an integer. So it takes in this array. It takes first thing it takes in a pointer to an integer, and it takes in an integer. First thing we're going to do is it's going to make a new array, right? Integer pointer, new array, and it's not going to point to anything. All right. Next thing, we're just going to check for size. We want to make sure that this actually has something in it. If the size is 0 or less, it's going to point to, it's going to just return a null pointer. Okay, there's not anything in it. This is just good programming to make sure that you take into consideration this condition. All right, next line. This is the important part. This is the dynamic allocation. Okay, it makes a new int array of this size, whatever size you sent it. So on the first one, we sent it size 5. So it made a new int array, size 5, and assigned it to new array, which we declared right here. All right. So remember, this right now is just a pointer. All right. But this treats it, this next line, this for loop, treats it like an array. So this is pretty simple. We've got array index, right? We've got a for loop, and it's going to go through size. So it's going to go through five different times. It's going to go through this. It's going to take the array index, which is the array that we sent it, which is the pointer to the array we sent it, right? And copy it over to the new array. So it's going to copy over 100 to the new array, 200 to the new array, 300 to the new array, 400 to the new array, right? And then after it's totally done, we're going to return a pointer. Remember, new array, I highlighted it here. Up here, it is a pointer, an integer pointer, and it's going to return that integer pointer and assign it to duplicate 1. So it made a copy of int array 1, and we assigned it to dupe 1. It's going to do the same thing with dupe 2. All right, I'm going to walk through it kind of quick. It's going to send this line here. It's going to send this array. And when I say array, it's basically a pointer to the first element. It's going to send the size, which is now 7, up to the function. Okay, so it's receiving the array, the pointer to the first element in the array, the size. Once inside, it's going to create a new array, an integer pointer, and assign it null. It's going to test it to make sure that it has some length, it has something in it. Then the next one, it's going to dynamically allocate a new array, right? And assign it to my array, which is an integer pointer. Now that we've got a new array, the same size as the array we sent it, we're going to copy it over. The array we sent, one element at a time, we're going to copy over to new array index 0, 1, 2, 3, 4, 5, 6, 7. Now at this point, we have an array, ARR, and then we, with the 7 items in it, 100, 200, 300, 400, 400, 500, 600, 700, and we have new array with the same things in it, the exact same contents. We return the pointer New array is an integer pointer. It points to the first element in that new array of 7 items. We return that pointer. Okay, and assigned it to duplicate 2. We do the exact same thing for duplicate 2, duplicate 3, I'm sorry. All right. The next lines are just printing it out. All right. I send array 1, again, it's just a pointer to the first element. Array 2, array 3, all are just pointers to the first element. There's no brackets here to say that we're sending it an array. We're sending it a pointer, all right? And then this prints it out. If we go up to that function, you can see it's rather short. It takes in the pointer, it takes in the size, right? It goes through the for loop for however many times the size is, prints out each index number of the array and a space. So in a straight line, we'll get all the items in the array. So here we're doing array 1, array 2, array 3, and then we're going to display the duplicates. Dupe 1, dupe 2, dupe 3. Same call. We use the same we use the same method as we used in the original in printing out the original array. Okay, we send it a pointer to the first element and the size. The size allows us to know how many times we're going to iterate or go through the function. Okay, I'm going to run this now. Oh, I'm going to first explain this. Guys, this program would run totally fine if we didn't do these next 6 lines. No problem. It would, I mean, I'll run it for you again to show you. This is just good programming. We dynamically allocated 3 different blocks of memory, all right? It's good programming to delete those blocks of memory. This is no big deal on these short programs, but if this was 50, 100,000, that's a lot of memory, right? So we delete the duplicates, and then we set the pointer to null pointer. Okay, delete everything and go ahead and assign null pointer to the duplicate. All right, I'm gonna go ahead and run this. Here's the original contents, right? Just like it looked in the code. And these are the duplicates. Remember, these 3 here are C outs of the original array. These 3 are dupe 1, dupe 2, and dupe 3. All right. After this program ran, it freed up all of the memory that we dynamically allocated. All right, I've taken out all of the code that frees up the memory at the end of the program. And as you can see, the program still runs fine. The memory is still being used though. All right, this is a tough topic to teach. It's a tough topic to understand. My recommendation is if you didn't understand this, go to 916. It's a page and a half in the book and study it, or maybe watch this video again. Like I said, I copied the code directly from the book, but this is important because this is pretty much how you'll see pointers used this semester. Very seldom do we just declare pointers pointers for just integers. It's usually almost always used in with arrays. All right. We can talk more about this tomorrow night. If you've got any questions, we can work through it. It's not one of the topics I'm strongest on. All right. Pointers aren't in every language, so they're not used all the time. But you can see this is the first video that actually shows one of the benefits for it. It is dynamic allocation. Again, this right here is static allocation. This right here is dynamic allocation. We're making these on the fly. We can make as many copies as we want of these, and we can do that on the fly. All right. I will see each and every one of you tomorrow night at 6 o'clock. I hope you enjoy the rest of your weekend. I hope you enjoy, I hope you're all watching the ball game, and I hope we win.